All right, so continuing on with our vectors here, we're going to talk about the unit vector. So a unit circle is a circle that had a radius of 1. A unit vector is a vector that has a length of 1. So for example, in number 10 here, it says find the unit vector that's in the same direction as v, which is 4i minus 3j. So just to give us a visual here, if we were to graph 4, negative 3, that would be this vector right here. So that would be vector v. Now I want the same exact vector, but instead of having it have length of whatever length it has, I want it to just have a length of 1. So this unit vector right here. So it's in the same exact direction, right? Meaning I'm not changing the angle, but I'm just taking it and I'm shortening it so that it has a length of 1. So in order to do that, we first have to figure out, well, what is the length of v? So the length of v we would find by doing the square root of x squared plus y squared. And we find out that the length of v is 5. So this length right here is 5. I want it to have a length of 1. So if I want this to have a length of 1, then essentially I need to shrink it, right, by 5 units so that it's only 1 unit long. And in math, when we want to do that, we're going to divide the vector into 5 equal parts, right? If I divided this into 5 equal parts, then it would only be 1 unit long. So we're going to take our vector v to find the unit vector, and we're going to divide its counterparts by our magnitude. This cannot simplify, so this is our answer. So, right, if we were to, let's say, find the magnitude of this new vector. So that would be 4/5 squared plus 3/5 squared. Now that should, right, if our math is correct, that should give us a vector that has a length of 1. And it does, right? So this vector right here would be 4/5 I plus 3/5 j, and it would be in the same exact direction. These two vectors have the same angle, but this has a length of 5, this only has a length of 1. Okay, so number 11 here, find the unit vector in the same direction. So in order to do that, we first need to find the magnitude of this guy. So that would be 2 squared plus 5 squared, which would give us 29. Root 29 cannot break down, so we're just going to leave it as root 29. To find our unit vector here, we're going to divide each of these by our magnitude. Now in this problem, we couldn't do any simplification, so we were done. In this problem, we do need to simplify. We shouldn't have square roots on the bottom. So we're going to multiply by root 29 on top and bottom, which gives us negative 2 root 29 over 29i plus 5 root 29 over 29j. Once again, we should double check. 2 over 29 cannot simplify. Good. 5 over 29 cannot simplify, so this is our final answer. Number 12, I'm going to leave for you guys to do. Keep in mind, if you can simplify a radical, then you should simplify the radical, right? So that's a little hint here. You're going to have to simplify the radical, which will make you do a little bit more simplification here. So I'm going to leave you guys to try that one on your own. So number 13 just makes us kind of think a little bit more here. So if you want to try 13 on your own, I definitely think that's a good idea. So 13 says a vector v whose magnitude is 7, so we know our vector length is 7, and the components in the I direction is positive. Okay, so the x is positive, that's what this is saying. The x is positive, and is equal to the component in the y direction. So our x is positive and it's equal to our y value. So let's say we were going to make a vector v, and we want our value in the x spot to be equal to the value in the y spot. So we want these two values to be the same, and we want them to be positive. Now, the other thing they told us is that the magnitude is 7, and we find magnitude by doing the square root of x squared plus y squared And we know that answer gave us 7. Well, to get rid of the square root here, I could square each side, sorry, which would give us a squared plus a squared equals 49, which would give us 2a squared is 49. Use our math here. Square root gives us a is 7 over root 2. All right, remember when we square root fractions, we square at the top, we square at the bottom. Simplify that here would give us 7 root 2 over 2. Now keep in mind this is not plus or minus, right? I know we took the square root, but we don't want plus or minus here, right? Because we want x to be positive. So because we want x to be positive, I'm choosing the positive version here. So it said find the vector, so our vector would be 7 root 2 over 2, comma 7 root 2 over 2. That is a vector that has a magnitude of 7, and the values are the same, and they are positive. Okay, so it just kind of made us think a little bit more there. So, speaking of creating vectors, okay, we're going to be creating vectors on this next page. So it says write a vector v in the form of ai plus bj that's given the magnitude and the angle. So we want to write our answers here. I want to find the vector. So we know the vector has a length of 100 and has an angle of 45. Now if we think back to polars, we were given some formulas to find x and y. Now if you think back, x was found by our cosine theta, and y was found by our sine theta. Now, in vectors, it's the exact same thing, but instead of calling it an r now, we're calling it the magnitude of v, and instead of calling it an r, we're calling it the magnitude of v. So if I want to find x and y, then I'm going to use my magnitude and my angle and plug them into these formulas. So we're going to have 100 cosine 45 I, because it says in this form, plus 100 sine 45 j. Now that's unit circle, so we can use our brains here. Don't use the calculator. Cosine of 45 is root 2 over 2. Sine of 45 is also root 2 over 2. Simplify here would give us 50, 50. So 50 root 2i plus 50 root 2j. So same thing with 19. I'm going to leave 19 for you guys to try on your own. Okay, so if you're given the magnitude and you're given the direction, we're able to write the vector that would match these two things. Now, in the bottom here, it wants us to go the opposite way. It's giving us a vector, and we want to find the direction, we want to find the magnitude. Now, remember, direction just means angle, and just like in our polars, to find the angle, we're going to do tangent inverse of y over x. So to find our angle here, we're going to do tangent inverse of y over x, which is the tangent inverse of -1. Now keep in mind that's on the unit circle, so this could be on a non-calculator part of your test. So make sure you're not grabbing your calculators in this moment. Now, tangent of -1 is at a 45-degree angle, right? So we know tangent is 1 at 45 degrees. However, we need to make sure we pick the right quadrant. So -3 would be in quadrant 4. So 45 degrees in quadrant 4 would be 315. So the angle is 315 degrees. Now the length we'll find by doing the square root of x squared plus y squared, which would give us 9 plus 9 or 18, which can simplify into 9 times 2, so 3 root 2. Okay, so number 21 here, we've got v is -2i minus 4j. So to find our angle, we're going to do tangent inverse of -4 over -2. Make sure that you're in degree mode. So tangent inverse of -4 over -2 would give us 63.435 degrees, right? However, this is in quadrant 3, and this is in quadrant 1, which means they don't match up. So remember, just like in our polars, we're going to have to add 180 here, which is going to give us 243.435 degrees. Then to find the magnitude, we're going to do the square root of 2 squared plus 4 squared, which is going to give us square root of 20, which can break down into 4 times 5, so 2 root 5. Okay, and then I'm going to leave number 22 for you guys to do on your own.